Alright, today I'm going to be talking about shell method and arc length. I believe that if you're preparing to take the BC test, you attended this live at some point. There may be some people who missed out, but I ran this like 3 times that week, and I taught it back in, December. However, for completeness and for fairness, this is the last thing I have to record in Unit 5. This is the only thing I have to record in Unit 5. Make sure you go back and do this homework. If you did Unit 6 first, this should be surprisingly easier. Unit 5's first assignment will not involve any of the awful things you've had to see do. Unit 5 for BC is the last section that's almost all AB topics, with this exception. So shell method and what I would call an introduction to arc length. Arc length will be much more incorporated in Unit 9. Shell method is just another way of getting a volume of revolution. So the key idea here is that for shell method, I'm going to draw my rectangles parallel to the axis of revolution. Remember, for disks and washers, the element was always perpendicular to the axis of revolution. So the way I'd talk about remembering this is parashell versus perpendicular. Now, this might make you groan. I don't really care. I'm not saying it's funny. I'm saying it's memorable. And memory is a finite resource on the BC test. You have to have a lot of things to keep in mind. And if you're not doing the homework, it's going to be tough to keep everything in mind, because that's how you memorize things. This moves. Oh, this is before I started locking everything down. Let's lock that really quick. Alright, so revolving rectangular elements around a parallel axis produces shells like the wrappings of a toilet paper. Now, I was not a fan of that. I prefer saying like paper towel. Here we go. I'm going to redraw, because maybe it's been a while since you thought about even the disk method. But here we go. So for the disk method, we'd have a shape like this. And we're going to take something like that. And if I'm revolving around the x-axis, right, I would draw my shape like that. And it would revolve, creating this disk. And that's why our formula was like pi r squared. Because there are a bunch of circles, and we're adding up a bunch of circles, la 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 la. For shells, the picture is similar but different. For shells, the same starting shape, I would want to draw, let's keep it consistent, darker color for this too. The same starting shape, I would draw something that was parallel to the axis of revolution. Parallel to the axis of revolution. And that represented rectangle would get spun around like this. So it's like a sheet of toilet paper or paper towel. And it's a cylinder. It's a cylindrical shell. That's why it's called the shell method. I'm using a cylindrical shell to model it. And what's the area? What's the lateral surface area of that cylindrical shell? Well, it would be 2 pi rh. In this case, it would be dy. So 2 pi rh, that's where the formula comes from. If you're complaining about a lot of memorization, I don't know. I know the formula by heart. I'm not that special. But one way to think about it is to think about it as a cylinder formula. The cylinder, like the volume and surface area formulas, should have been easy in 3D, depending on 3D. Depending on who you had, they should have taught you that this is just circumference times height, right? And you know the circumference formula. You memorized it. You were good. You know the area formula, right? It's circumference times height. That's how you get a surface area for any like normal shape. Okay. Now we're always going to make sure r is bigger than 0 and h is greater than 0. This will take care of itself, as long as you keep in mind right minus left, top minus bottom. Because it's not mentioned explicitly anywhere in the notes, I'm going to say r is the distance from, well, no, let's just say distance between. That's more neutral. Distance between axis of revolution and rectangle, and I would say h is the length of rectangle's long side. Okay? So those are some things to keep in mind. I'll try to make this as clear as possible. I'll try to make this as clear as possible. Okay. Ready, steady, go. So, in example 1, see, some of this stuff's locked down. In example 1, they give you a picture. They ask you to find the volume of the solid by revolving the region bounded by x squared plus 1, the parabola-looking part, y equals 0, another name for the x-axis, x equals 0, another name for the y-axis, and x equals 1. This guy about the y-axis. So the y-axis, I wanted something that was parallel to the axis. That was parallel to the axis. I know it's not colored in. Okay. The height of this tall rectangle was x squared plus 1. The long side was x squared plus 1. Why? Because it's x squared plus 1 minus 0. Top minus bottom. The width of any rectangle this way is dx. Anytime we are looking at a vertical rectangle, I'll write it down somewhere. Vertical rectangles for both methods. Vert rectangles, dx. Horizontal rectangles, dy. I'm sorry, someone texted me. So, dy or dx rectangle, it's a dx rectangle because it's a vertical rectangle. Now, r is the hardest part. I am not even kidding. R is the hardest part to understand. So first, in order to do left minus right, or sorry, right minus left, left is easy. Left is easy in this case. That guy's x-coordinate is 0. The hard part is what is the x-coordinate of the representative rectangle. And at this point, a lot of people try to get like, oh, it's like 0.8 or 0.6 or 0.7. You're not supposed to guess. The idea is that this rectangle will move from here all the way to here, covering the shaded area. What does that mean? What does that mean for us? That means it's always changing. Its distance along the x-axis is changing. It's variable. Its x-axis variable is x. So it's x minus 0. Tall rectangles will usually have x as the location of the rectangle. Will almost always have x as the location of the rectangle. Always will have that location as an x. A horizontal rectangle will always have its location in terms of y. Okay? So, x minus 0. So the volume here, 2 pi. It's always going to be 2 pi. R, x minus 0, h x squared plus 1 minus 0 dx. Bounds. Where will the rectangle start his life? He'll start his life at 0 and his life at 1. That sounds dark. He'll start at 0, stop at 1. Now, as a quiz in the live session, I would ask people how they would integrate this. Some smart cookies were saying like, oh, you could use reverse chain rule idea. Like the derivative of the inside is right here with a 2. I need to make a 2. And they would get something interesting. You don't need to do it that way. When it's good old-fashioned multiplying with polynomials, you can just do that. 0 to 1, x to the 4th over 4, plus x squared over 2. Oops. Oh my gosh. I did mess up. Sorry. It's like, oh, it should have been done by now. Why wasn't it done? Because I didn't do that. Plugging 0 into here will make 0. You shouldn't ever assume that, but you are allowed to, use your brain. And we're done. Ta-da! And that's shell method. That's the basic form of shell method. Thanks. Good? Why would using the disk method for this problem be so much harder? And if you don't see how it's so much harder, prepare to be amazed. So let's erase all that. I wasn't done copying. Well, just remind it. Pause it now. I don't know. If I was doing perpendicular, my rectangle would look like that. Or at least one of them would. What? One of them? Yes. Because then you would also need these rectangles. Why would I need 2 rectangles? Because the right minus left would change as I moved through it. The right minus left would change as I moved from bottom to top. So, one reason is it would need 2 separate integrals. That's an R somehow. It's 2 separate integrals. What's another reason? How would you get right minus left? 1 minus 0? Very good. How about here? 1 minus, if you said it without x squared plus 1, you're wrong. You would also need to solve for y. Why do you need functions of y? Because it's because it's a horizontal rectangle. And horizontal rectangles always have width, dy. Okay. In case you're curious, in case you do not believe me, we'd have this integral from 0 to 1. Disk method for the red guy. 1 minus 0 squared dx. Sorry, dy. See what I'm saying? Plus pi. Shell method. Not shell. Oh, gosh. Washer method. From 1 to 2. Y coordinates, guys. 1 minus 0 squared minus 1 minus square root. Oh, isn't it great? Y minus 1. dy. Now, this integral is almost impossible to do by hand. It's not literally impossible. It's just almost impossible. You wouldn't want to do it. So certain methods, the shell method is easier. It will avoid a lot of that nonsense. That was easy. That was simple. That was clean. All right. Less structure over here. Set up but don't integrate an integral giving the volume of the solid formed by revolving this region about the y-axis. So I'm going to go about the y-axis, womp, So I wanted a pair of shell. Okay. Again, we're thinking, where is this rectangle? Oh, it's a vertical rectangle? So then it's at x. Here's the axis of revolution. Where is that? It's at 0 always. It's not moving. X minus 0 equal x. Now, what's the height? Top minus bottom. This was right minus left, by the way. Top minus bottom. What's the top curve? Oh, the parabola-shaped one? Good. And minus the bottom. Look how it's a double negative, guys. Okay? Okay. Now, I honestly don't like you to simplify it. I don't think your readers want it either. The readers just want you to write it in a clear way. It's clearly top minus bottom. If you can't resist, it's definitely 3x minus x squared. Sometimes I can't resist either. Okay? So we're going to have a nice integral. 2 pi integral r h. Told you. Just wouldn't leave it like that. I see a lot of students struggle with not writing a square. I almost wrote a square there. Don't do it. The shell method's nice. It has no squares in it. Well, no squares on the outside. No squares on the inside. Bounds. How do I find the bounds? How do I find out where this red rectangle will start and end? Now, many of you may think, oh, is that 0? Don't assume. Try it. 0 in here. 2 times 0 minus 0 squared. 0. 0 in here. Negative 0. Oh, that's also 0. Great. So it starts at 0. It stops at where? Again, what they really want you to see, what they really want you to do is, okay, for the bounds, we're trying to find out where they intersect. So we set up this equation. Oh, negative. Factoring is important. Factoring is fundamental. If you can't factor, I don't know. 0 to 3. You could just guess and check. That's a really dumb way to do it. But if you somehow forgot how to factor on the AP test, try 1. Oh, that didn't work. Try 2. Oh, that didn't work. Try 3. Oh, look, that worked. I wonder how I could have done it. Factoring. Alright, now use both the shell method and the disk method for the same problem. That's all this is. Alright, so highlighting the differences, highlighting the similarities. Now this is one I skipped when I did these in person. So maybe this is new for people. I'll mention that in the email where I talked about sending these out. I'll use a shell first. So let's do shell. When I did this live, I said, hey, you should try these out. Try it out. Pause the video. Try it out. I'm going to do shell first, then disk if you want to have your work organized. Okay. 3, 2, 1. Shell. I'm going around the x-axis. Hopefully you caught that before you pause the video. You can always pause again and try. Oh, God, the x-axis. All right. So para shell. Chunky looking rectangle. Okay. So it's a horizontal rectangle. It's definitely going to be a dy. Just going to set up some things I need. I know it's going to be dy because it's a horizontal rectangle. Okay. Now, in this case, r is the distance from the axis to the rectangle. Where does this rectangle live? Where does the axis live? The axis always lives at coordinate y equals 0. A horizontal rectangle always lives at coordinate y. So we're definitely going to have y minus 0. Probably not going to notice this. That's what's r. Top minus bottom in this case. It changes. H equals now h Oh, I don't want to write that there. That's dumb. H is about how tall is that rectangle. Left minus right. What's the left-hand side? 2 minus the right-hand side. You would need to solve for y. You would need to solve for y. Why do I need to solve for y? Because it's a dy integral. Because it's a horizontal rectangle. So solving this for y should be easy for you guys. Cube root. Oh no, I can't write it. It's not easy to write, but cube root y. So times 2 minus cube root y. Now we're going to do this integral for good measure. So again, if you haven't actually found the volume, take a second to do that. Oh, bounds. I'm sorry. Bounds. Starting here, going until 8. How do I know they intersect at 8? Because when you plug 2 into this function, you get y equals 8. So 2 pi. How'd you do this integral? I could have asked a bunch of people. And I might get very different answers. You definitely are just supposed to multiply it out. 2y minus, what's y to the cube? Sorry, what's y cubed? What? Oh no, it's what's cube root of y? Y to the 1/3 power. So times y, I get y to the 4/3 power. 2 pi. Y squared. Add 1 to the power, divide by the new power. Minus y to the 7/3 over 7/3. And if you want to start multiplying by the reciprocal instead of dividing by 7/3, you feel free. When I plug in 0 in here, I'm getting 0. 64 minus 8 to the 7/3 power. If your first thought was, oh, let's do 8 to the 7th, you're crazy. Do 8 to the 1/3 first. 8 to the 1/3 is 2. 8 to the 1/3 power is 2. The cube root of 8 is 2. 2 to the 7th is 128. So 3 times 128 over 7. If you simplify it, I'm just going to simplify it just so, hey, look, it's giving me the same formula. You get 128 pi over 7. Don't believe me? I don't know. I bet it works. I checked. Shrinky. Over here now. That still kind of works. Cool. Over here, second chance to listen to me and do a washer. Is it a washer or is it a disc? Pause the video. Try it out. 3, 2, 1. Disc method for sure. Why is it disc method? Because the axis of revolution forms a boundary of the region. What does that mean? The axis of revolution here is a whole side of the shaded area. It's not just, I don't know what's going on down there. It's not just some random thing, right? It's not just some random, it's not touching it for a second. A lot of people want to do washer as soon as it, disc as soon as it touches the boundary. This axis revolution, oh wow, I'm drawing with the other end of the pen. It's dumb. This side, the axis of revolution, is an entire side of this gray area. I can't emphasize enough. That's the only time you use disc. If you wanted to do it here, this would also have been a washer. This would have been a really difficult washer. This problem would have been almost impossible to do using disc/washer, FYI. But this would be a washer, because the axis is not making a whole side of the gray area. It touches it once, but it doesn't make a side of the gray region. This is a disc because the axis is a side of the gray region. Pi. Now, so I'm going to draw perpendicular. Okay. Where does that rectangle have to travel from? 0 up until 2. 0 to 2. And how tall is it? That would be the radius of the circle that's revolving. It's x cubed minus 0 squared pi r squared. So one of the goals of this is for you all to realize that sometimes one of these will be vastly better than the other. And ideally, if I had more confidence, you would all clearly say, oh, you know what, Mr. Leven? Usually I'd be better with disk because I knew it better. But you should also leave this lesson having a deep appreciation for shell. Shell is a lot easier. It's not a lot easier when you have to solve for y first. So what I would do is I would see what's the problem trying to guide me toward. Are they giving me functions for x? And if I use shell, I'll use functions of x? Then I would always try shell. If they're giving me functions of y, and if I use shell, I'd be needing functions of x, then I would try a disk, okay? Whenever you do this, shell will require x or y, and disk / washer would require y or x, the other one. They're always going to use different variables, dy, dx. If this was dx, that would be dy. So use whichever one's easier. The whole goal of this lesson is for you to develop fluency with it. This example is designed to show you how flexible shell method can be and how interesting it is to just be able to use shell method repeatedly. You know that sometimes on your homework for washers and disks, you have to do like the same thing with 8 different axes of revolution. Here's 3 different axes. Let's see how it changes. So your first step is always to draw y equals the square root of x minus 1. That's the square root function shifted 1 to the right. Something like that. A half of a sideways parabola, you may have said. Sure, whatever. Y equals 0. That's this side. X equals 5. It's right here. Right here, guys. So let's shade this area. I don't know. Oh, I kept that color for some reason. Oh, it's so ugly. It looks like the orange color. Orange color. Ha ha ha. La la la. Coloring. Okay. So now I'm using the shell method. Why? Why do I have to use the shell method? Because they told me to. They can do that. They can. Sorry, I drew that there. It shouldn't be there yet. Cough, cough, cough. Using the shell method, let's revolve around the y-axis. I'm going to use green for this problem. The y-axis is right here. Pair a shell. Drop this somewhere. If I drop it here, everyone's going to be like, oh, where's the rectangle? 3. No, it's not 3. What kind of rectangle is it? It's a vertical rectangle. It's a dx rectangle. Cool. So we're going to be using dx. 2 pi integral something something dx. That's probably way too much space. Okay, so in this case, the radius is the distance from here. Remember, a vertical rectangle is always located at x to here. Right minus left, my radius will be x minus 0. How tall is this rectangle? Top minus bottom. Top minus bottom. Luckily, it's already in terms of x. Root x minus 1 minus 0. Where will the green rectangle start? Where will the green rectangle end? Again, my only goal is to cover this whole shape. The green rectangle to cover the shaded area will start at 1 and it will end at 5. Now, a lot of people when I did this live had an issue with that. They thought it should start at 0. 0 is not part of the shaded area. There's nothing over here. Definitely going to start at 1, end at 5. Cool? I mean, I'm happy. I hope you're happy. In blue, x equals negative 2 is somewhere over here. I know many of you know exactly where it is, but I can't really draw it that well. Still 2 pi. If we're rotating around here, we're still parashell. My rectangle will still be located at x. X minus, where's the axis located? Negative 2. So that's a very key part. Right minus left is now x minus negative 2. The radius piece is what's keeping track of the axis of revolution for you. And now that I said that, it should also be clear, this blue rectangle also has height. Top minus bottom, root x minus 1, minus 0. Sorry. And again, it will start at 1 and end at 5 when it covers all of that pale, gross, yellow area. No! That spoiler, sorry. X equals 5. I already drew it. Hooray! Still parashell. Now, where is this guy located? It's located at 5. So now, let's draw some stuff. So now, right minus left is a little different. Now, right minus left will be 5 minus x. Right minus left, okay? Pay attention to that. That's the confusing bit for a lot of people. Minus 1, minus 0. The height of the pink rectangle is still that. And the pink rectangle will still travel from 1 to 5. So the reason this example is so important is it shows you that all that's changing is this component, the radius component. The distance your rectangle is from the axis of revolution is the only thing that changes. Okay? Same bounds, same 2 pi, always dx, because all the axes were vertical. Anyway, vertical, I said. So my rectangle was always vertical. Questions, you gotta come in and ask me. I keep having a natural instinct to ask you guys. Sorry, something just banged on the window and I'm a little jumpy. You gotta come in and ask me. You gotta do these assignments. You gotta check your answers. Okay. Find the volume of the solid formed by revolving the region bounded by x equals y squared and x equals 4 about the line y equals negative 3. What's this? Oh, that's a sideways parabola, you might have said. I've seen worse parabolas. X equals 4 is some sort of crazy vertical line, wavy vertical line, about the line y equals negative 3. Now, honestly, a hard part of this for people is to think about where this line is. I'm going to shade really quick, just so we all see what we're talking about. Sorry, I got outside the lines. I don't care. It's so ugly, this color. I should really stop using it. But the bright yellow is too bright, and you can't see the rectangles. Okay, anyway. Let's talk about where these intersections are. As always, how could I find these intersections? You can set the equations equal to each other. This is y. Oh, sorry. This is x. That's y. X. 4 equals y squared. Y equals plus or minus 2. I'll give you 5 guesses about which one of these is plus 2 and which one of these is minus 2. If you said this one had coordinates 4, comma, positive 2, and this one had coordinates 4 comma negative 2, I'm very proud of you because it means you understand, I don't know, that this is the positive y-axis and this is the negative y-axis. How do I know its x-coordinate is 4? X equals 4. Anyway, so where is this line? It's below the figure. It's below somewhere, and I don't care how you draw it. It just cannot be here. It cannot be here. It cannot be touching that point. All right, we're going to revolve around this line. All right, para shell. I'm going to keep using shell method. Could you use disk method or washer method? Yes, but notice your rectangle would look like this, and this is exactly the type of problem we talked about when we first went over disks and washers. We said that this would be hard because calculating this and that, calculating top and bottom was very difficult. So I'm going to use shell. So there's my representative rectangle. Okay. I want to connect them up there, sorry. All right, R. The rectangle's position is at X. This guy's position is at negative 3. So we're going to use a top minus bottom approach. X minus negative 3 times, how tall is the rectangle? Right minus left. It should be 4 minus, now what am I doing with respect to? Oh, you guys aren't here to correct me. Ha ha ha. So I don't know. I could play that off as I'm just trying to do it. How do I know it's going to be dy? I should have done that first, really. Why do I know it's going to be dy? Because I have a horizontal rectangle. Horizontal rectangles are always dy. And that would have helped me think about y minus negative 3 times. I'm going to leave that error in. I could edit it out. It's important for you to see me make mistakes. It's okay. Sometimes you make mistakes, but you correct them. See, I caught myself when I went to check about how we would have to solve this, okay? Horizontal rectangle, dy. Everything needs to be in terms of y. Right, 4, minus left. What's this bound? Guess what? I get to use y squared. Not x equals y squared. Don't put equals inside here. That doesn't make any sense. It's nice. You don't have to solve for y, which is what you would have to do for the disk method or the washer method. Now, to cover the entire span, my rectangle would have to start down here and go all the way up here. Okay, so we're talking about negative 2 to positive 2. So if I wanted to find the volume, I'm going to write it down. Y plus 3 times 4 minus y squared. I would get 4y minus y cubed plus 12 minus 3y squared. Power rule, people. Power rule. 2y squared minus, that's a 2 somehow. Y to the 4th over 4 plus 12y. That 4 looks like y. I'm just so good at writing y's. Even my 4's start to look like y's. From negative 2 to 2. In this case, you have to plug everything in, people. 2 times 2 squared, 8. Minus 16 over 4 plus 24 minus 8 minus all, parentheses, negative 2. Even exponents, still getting 8. Even exponents, still getting 4. Negative 4. Let's put that over there. Odd exponents. Odd exponents. All times 2 pi. So what I'm thinking about, ocho, cancel with ocho, negative 4, cancel with negative 4. 24 minus 24 is 48. Negative 8 minus 8, I would get 64 pi. Okay? Whew, that was fun. Again, dy, because it's a horizontal rectangle. No question about it. It's always dy. Top minus bottom for the radius, right minus left for the height of the rectangle, along side of the rectangle. Now, this is the same problem. This is the same problem with a different axis of revolution. Ready? Mind blown. I know, not really. Okay. Same problem, different axis of revolution. So you only have one picture. That's okay. All you need to do is draw the other axis. This is along the line y equals 3. That's up here. Again, a key thing, it's above 2. It's above 2. Still parashell. Still parashell. Still a horizontal rectangle. So I'm still going to use dy. Negative 2 to positive 2 still. To cover the entire shaded area, the pink rectangle has to start down here, move up here. The radius, the distance from the axis of revolution, which is at height 3, to my pink rectangle, which is at height y, top minus bottom this time will be 3 minus y. The height of the rectangle would still be 4 minus y squared. So that's a setup. That's all it asked for. Just asked for a setup. I can assure you this would compute out to be the same thing because of the symmetry. Okay? Uno mas thing to go over. Arc length formula. Again, this seems really tacked on, but it's because it's so easy. It's so easy. You'll see much more of this in Unit 9, which is right around the corner for my live teaching in the actual BC class. Here's the formula. 1 plus f prime of x squared, all in a square root. So we're thinking, where does this formula come from? It's helpful to see. We're thinking that along some curve, and again, this is something I left out of the live part, so you're welcome, everybody. Along this curve, I would like to calculate the length of a little tiny piece. A key idea of calculus is that the length of a little tiny piece is linear. Okay? That's a linear piece. So if I blow this up even more, the idea is that this piece can be broken down into a triangle if it really is linear locally. And this is a tiny change in x. This is a tiny change in y. So the black side, by Pythagorean theorem, would be the tiny change in x plus the tiny change in y. I can factor out dx squared. I can simplify things, or at least write them in a very misleading way, or not misleading, but very clever way. So what do I want to add up? I want to add up a bunch of these things. And that's what the point of that formula is. It's like, we're going to add up all these little lengths, and that's the way we're going to calculate the whole length, which this is f prime. So that's where it comes from You don't have to know this. You will see this formula in Unit 9. Alright, so how do I use the formula though? So stupidly easy. Hey, I need f prime. Right? So the arc length. Sometimes the readers will like to see that. 1 plus parentheses. You got to keep your parentheses, people. The x is outside. Now where do I want to start counting? I want to start counting at 0. Stop counting at 2. Interval's right there, guys. Now, how can you integrate this? U sub? No, 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 no. Not U sub. You're just going to go for it in the calculator, okay? Arc length is almost always on the calculator section. At least arc length like this. You should be able to type it in your calculator and get that. Okay, that's it for 5-1. I've officially finished everything up to 7 in terms of my recording. Cool. This is the only thing similar to AB. Make sure you do the lesson for 5-1. You do the assignment for 5-1. BC 5-1. Duh. It's very important that you're doing the assignments, not just watching these videos. I can guarantee you will not do well if you just watch the videos. I'm pretty good at explaining. I'm not that good. Ask questions, come in, talk to me about any kind of thing you want to. I'm here for you guys. I appreciate your hard work. You guys have a wonderful day or night whenever you're watching this video. Keep up the hard work. Talk to you later. Bye-bye.